Good evening students, very good evening to all. Today we are seeing about the topic PN junction diode. First we see about the diode. The name indicates diode. D-I-O-D-E. Di means two, diode means anode and cathode. Here two layers are presented. One is P layer, another is in N layer. In the P layer, the anode is presented. In the N layer, cathode is presented. In order to see the PN junction diode, we want to see the semiconductor. You want to see the semiconductor devices. Semiconductor is nothing but a type of a material. It acts as a conductor, not also act as a non-conductor. For example, for semiconductor, silicon and germanium are the both examples. First, the best one is called silicon. We are rejecting the germanium due to two reasons. The one is the silicon is an abundant one, but germanium is not an abundant, it is less amount. The second thing is the silicon is not damaged by water and acid, but germanium is easily damaged by acid and water. Due to these two reasons, we selecting the silicon as a major semiconductor device. If we use silicon in a pure form, it is called intrinsic semiconductor. In intrinsic semiconductor, the conductivity is very less. So we are adding impurity in the pure silicon. This process is called doping. The impurity added is called dopants. So, when a pure silicon is added with a impurity is called as extrinsic semiconductor. Externally, we are adding the impurity to the silicon. So, it is called as extrinsic semiconductor. In extrinsic semiconductor, we are adding two types of impurity. First one is called pentavalent impurity. First of all, we know that silicon has a valence electron of 4. We are adding a pentavalent impurity. Penta means 5. This also called as donor atom. So, this donor atom donate 4 electrons to the silicon. So that once the electrons from the donor atom goes means there will be holes presented. Hole charge is plus. If we see the silicon atom, in silicon atom already 4 electron is presented. This donor atom donate 4 electrons. Therefore, in silicon there is 8 electron. But in silicon there is no holes. So, majority is electron, minority is holes. So, it is called N-type. Therefore, in N-type, majority is electron, minority is holes. The second process. With pure silicon, we are adding acceptor. That is known as trivalent impurity. Tri means 3. Here, this acceptor atom accept the 4 electrons in the silicon. So that after the 4 electrons have gone from the silicon, the holes only present in the silicon. So, in silicon atom, the majority is holes, minority is electron. So, it is called p-type. Therefore, in PN junction diode, the p-type has majority of holes and minority of electron. The N-type has majority of electrons and minority of holes. Therefore, it forms an P layer and N layer. In between that, there is a junction. The diode, it works in a two process, forward bias and reverse bias. We will see on this lecture in later video. Thank you.